Hello students, so here we are with the question first of the exercise 4.1 for the chapter Quadratic Equations. The question first is check whether the following are quadratic equations. So the first equation being provided is x plus 1 whole square is equals to 2 into x minus 3. Before proceeding with the questions, let us see what is the standard form of the quadratic equation. If we see the standard form of the quadratic equation, it says a into x square plus bx plus c is equals to 0. What it means is that if the highest power of the x is 2 and the coefficient a is not equal to 0, then definitely that equation will be called as quadratic equation. So the condition we have imposed over the equation to be quadratic is that the coefficient of the x square should not be equal to 0. So what it means is that in order to proceed with the questions, that is in order to conclude whether or not the equations being provided in the question is quadratic or no, I just need to check the coefficient value a in them. If it's 0, then that equation will definitely be not the quadratic. If not equal to 0, that is I have some value for the coefficient of x square, then that equation will definitely be called the quadratic equation. Now coming to the a part of the equation, here the equation being provided is x plus 1 whole square is equals to 2 into x minus 3. Right. So first step I'll be doing here is to simplify this equation in the form of the standard equation. So I am using the identity over here. As the identity which can be used is here, a plus b whole square is equals to a square plus b square plus 2ab. And as a in this case is x and b is 1, so using the identity I'll get x square plus 1 plus 2x will be equal to 2x minus 6, right? Now taking the right hand terms to the left hand side, I'll get x square plus 1 plus 2x minus 2x plus 6 is equals to 0. Now cancelling the common term, that is minus 2x and plus 2x on the left hand side, I'll be getting x square plus 7 is equals to 0. And if I compare this equation with the standard equation, clearly the coefficient a is not equal to 0 in this case. What is a? That is 1. That is the power of the x square is 1 in this case. So definitely this equation will be, yes, this equation will be the quadratic equation. Right. Now coming to the second equation being given as x square minus 2x is equals to minus 2 into 3 minus x. Now again simplifying this and converting it to the standard form of the equation, I'll be getting x square minus 2x is equals to minus 6 plus 2x. Now taking the right hand terms to the left hand side, I'll be getting x square minus 2x plus 6 minus 2x is equals to 0, right? Or I can write it as x square minus 4x plus 6 is equals to 0. And if I compare this equation with the standard equation here, the a value is 1. That is the coefficient of the x square is 1. And the equation to be the quadratic has been satisfied, that is has been fulfilled condition. So I can conclude over here that yes, this equation is also quadratic equation, right? Now coming to the C part here, the equation is x minus 2 into x plus 1, which is equals to x minus 1, x plus 3. Now again simplifying this, I'll be getting x square minus 2x, right? And then plus x minus 2, which is equals to x square minus x plus 3x minus 3. Simplifying this, I'll be getting x square minus x minus 2, which is equals to x square plus 2x minus 3. Now taking right hand terms to the left hand side, or I can take other way around as well. That is left hand side terms to the right hand side also. The choice is being yours. Here I am taking right hand side terms to the left hand side. So I'll be getting x square minus x minus 2 minus x square minus 2x plus 3 is equals to 0. So simplifying them, I'll be getting minus 3x plus 1 is equals to 0, which means that here the value of the coefficient a, comparing it with the standard equation, is equal to 0. That is, there is no term of x square here. So definitely I'll be concluding here that no, this equation is not a quadratic equation. Now coming to the fourth equation, it's been given x minus 3 into 2x plus 1 is equals to x into x plus 5. So simplifying it, I'll be getting 2x square plus x minus 6x minus 3 is equals to x square plus 5x. Now again taking the right hand terms to the left hand side, so I'll be getting 2x square plus it's minus here s plus x minus 6x is equals to minus 5x. So minus 5x minus 3 minus x square minus 5x is equals to 0. So simplifying it, I'll be getting x square minus 10x minus 3 is equals to 0. Clearly the coefficient value a is equals to 1 in this case. That is, we have some term which is being related to the x square. That is, we have the term x square in this equation. So clearly this term, or I can say this equation, is a quadratic equation because the coefficient value of the a is equals to 1, not 0. Now coming to the e part, here the equation being provided is 2x minus 1 into x minus 3, which is equals to x plus 5 into x minus 1. Simplifying it, I'll be getting 2x square minus 6x minus x plus 3, which will be equal to x square plus 5x minus x minus 5. So taking the right hand side term to the left hand side, so I'll be getting x square, that is 2x square minus x square comes out to be x square, minus 7x and plus 4x is equals to minus 3x. Right? I hope you are getting what I'm doing. I'm just doing the calculation. You can do step by step as well. It's being your choice. So here it will be plus 4x, minus 7x and minus 4x. Here it will be. This is the mistake you can done. That's why I was not writing the steps. So don't forget to write step by step procedure, okay? So here it will be x square minus 7x minus 4x comes out to be minus 11x, and then plus 3 plus 5 is equals to plus 8, which is equals to 0. So clearly here a is equals to 1, which means that yes, this is also the quadratic equation because the coefficient value of a is equals to 1, not 0. Now coming to the f part, here the equation being provided is x square plus 3x plus 1 is equals to x minus 2 whole square. Again, I need to first convert this into the standard form and then compare it with the standard equation and see whether its coefficient a is equals to 0 or no. So here it will be x square plus 3x plus 1, and using the identity it will be x square plus 4 minus 4x. So taking left hand side terms to the right hand side or right hand side terms to the left hand side, I'll be getting 7x minus 3 is equals to 0. Clearly, I don't have any term related to the x square, so here a is equal to 0, which means that no, this equation is not a quadratic equation. Okay, now coming to the g part, here the equations being provided are x plus 2 whole square plus 2x into x square minus 1. So simplifying it, I'll be getting the equation x square plus 4 plus 4x, which is equals to 2x cube minus 2x. Simplifying it, I'll be getting 2x cube minus 2x minus x square minus 4x minus 4 is equals to 0. Or here I can write it as 2x cube minus x square minus 6x minus 4 is equals to 0. Now, if I observe this equation, clearly the highest power of x in this case is 3, not 2. Means this is a cubic equation. That is, the identity of the equation to be the quadratic has been changed. As for the equation to be the quadratic, the highest power of x needs to be 2. But in this case, it's 3. So this equation is the cubic equation. Though the coefficient of the x square is not equal to 0 in this case. But this equation will be called cubic equation. So we can say, no, this is not a quadratic equation. Now coming to the h part, here the equation being provided is x cube minus 4x square minus x plus 1 is equals to x minus 2 whole cube. Now, just by seeing the equation, we can't conclude that this will be the cubic or the quadratic equation or a linear one. We need to solve this and convert into the standard form, and then only we will make any conclusion, right? So here we can see that we can easily apply the identity, that is a minus b whole cube. So here it will be x cube minus 4x square minus x plus 1 is equals to x cube minus 8 minus 6x, and the bracket will be x minus 2, right? Now, which will be x cube minus 4x square minus x plus 1 is equals to x cube minus 8 minus 6x square plus 12x, right? Now, just simplifying this by taking the right hand side terms to the left hand side, I'll be getting, as it's been clear that x cube and x cube is there in left hand side as well as in the right hand side. So means it can easily be cancelling out. So here I'll be getting is 2x square minus 13x plus 9 is equals to 0. This is 9. So as I can see clearly that the highest power of the x in this equation is 2. And the coefficient is not equal to 0, which is 2 in this case, right? So that means the condition for the equation to be quadratic, that is the highest power has to be 2 and its coefficient needs not to be equal to 0, both have been fulfilled. So I can easily conclude that this equation being provided in the question is quadratic equation. So yes, this equation is quadratic equation. So this was about first question of exercise 4.1. I hope this question is clear to all of you.